No,
Oh, yeah.
So just make this really clear. Homework for chapter 3 is due this Wednesday. Yeah, so if you didn't do much homework this past weekend, go back in time, slap your past self, and come back. Yes? No, test corrections are due the day of the next test. This... Alright, did I already say that? Fine. I'm trying to help you. The best way to get ready for graded anything is to have the homework done. So let me say this then. Fine. Because I didn't think you guys could handle this. But yes, the probably chapter homework, you can turn it in on the day of the next test. But what do you probably want to do for yourself to be nice, to be ready for the test this Wednesday? The quiz? You probably want to do some homework out of all the sections so you're ready. Right, the best way to get ready for a big quiz like this or a test is to have the homework done. If you're not going to have enough time to do it, because you didn't get enough done this weekend, then you can still focus on all the sections. I'll just leave some sections totally undone because then you won't have a clue how to do that. Yeah.
I see in the class when the test corrections were due, and they said this Wednesday, but...
No, I don't think it did.
No. It's the next test.
Next test. Test and quiz corrections always due by the day of the next test. This Wednesday is a quiz. Yes. Okay, I like it. Yes.
It's just all chapter 3.
Totally. I like it. So forgive me for it saying chapter 4 up there. It used to be chapter 4 in the old book. So it's chapter 3, okay? Chapter 4 was probability in the old book. I love you guys. Love you guys so much. All right. So you focus on understanding. So everything I do is trying to get you to understand. So this is the same quiz I've used forever because it's got everything I need. I just forgot to change chapter 4 to chapter 3 when I changed books. All right. I would hope, if you really thought it meant chapter 4, I would hope you would have brought it up before today. That would have made sense. All right. So let's first do the formula sheet. And remember, I hope you understand this. The formulas will get in your way if I give you like a table of values. I've said this a few times already. But trust me, people try to force in the formula and you don't use it correctly. It's much easier just to count stuff. And we'll see that here in a minute. So we have the basics. We have the A or B. What's that formula?
P, probability of A plus probability of B minus probability of P and B.
Okay. And the idea behind this is if I say A or B, it could be A. I'm going to count everybody in A, everybody in B, but I might have counted some people twice. So the idea behind that makes sense, and it makes the formula easy to remember. You don't have to even remember it. You can just put it on the formula sheet. Now remember, some of you guys lost points on the first test because you put extra stuff on the formula sheet. You can cry as much as you want to. I don't care. You know that you can't put extra stuff on the formula sheet, just the formulas, to make it fair for everybody. So please be careful. All right. What about, let's do this one. Let's do A given B.
Probably A and B over probably.
Yeah.
Probably A and B.
And finally, this one comes right off of this. Just multiply that up. And even if you want to, if you can figure out what this means, or either way works. Either way works. Probably B times probably A given B, or the probability A times the probability B given A. Doesn't matter. They both work the same. Let me think. Is there anything else from chapter 3? Those are ideas. You can't put ideas down on the formula sheet. Oh, that almost made me decide to let you do that, but no. Yeah, I'm sorry I make you understand ideas. I do. It's my job. I just feel like, I don't know, other math teachers, did they make you do homework and check it?
No. Yes.
Sometimes.
They miss an opportunity.
I think more and more teachers are doing like online, or they just don't even look at the homework. They just make you do it, turn on the test, they don't even look at it.
Yeah.
So some of you guys are not used to a person who actually does their job and looks at your freaking homework. All right, I'll let you. Any other suggestions that I could shoot down for, or that I might not shoot down, but I probably will? All right. No more suggestions for the formula sheet? Okay, so that's it. That's all that can be on your formula sheet. That's it. No explanations, no words, no examples, no anything else. You can have the words formula sheet on there. What's up? Sorry? I understand. They're there. Or, and.
You can't write down the names of the ideas I have.
It's in the formula. There's the word or. What's happening? Okay, I will. All right, so now let's look at this practice quiz.
Wait, yeah.
Yes.
Can we write
Yes,
down
student.
like the just mutual exclusivity, or like the actual idea, but not the logic behind the idea?
No.
Okay.
Thank you, though.
Yeah.
You gotta ask. All right, guys. All right. So let's go through this. If I remember, maybe if somebody emails me, I can send you a scanned copy, but you should be able to. Yes, do that. And I'll actually do that. All right. Guys, shut up. Hey. So for this first one, a really good place to start is that 26% is obviously kind of important. What symbol would you give it?
D.
D. I love it. D for dislike. That's crazy. So probably dislike the plan is 0.26. So what's the probability that they like the plan? 0.74. Like. So that would be you being nice to yourself. It's crazy. It's a crazy idea. Can somebody write then in the symbols that we chose what the situation is that I've laid out here? What's the situation that I laid out here using the symbols we chose? The first two disliked it and the third one liked it.
Here, D and D and L.
So DDL. It's crazy. So this situation is DDL. Does that make sense? You guys see that? The probability I have the first two dislike it and the last one like it. Now I just said a magic word, and the word but, B-U-T, is and hidden in English, right? If you replace the word but with and, it still makes sense. So but is another way to say and. And is very often hidden, and it's just English's fault. Math is like, where the hell is that and? So what am I going to do with these probabilities to figure this out? Multiply. And means multiply. So I want the first one to dislike it. How many empty spots do I have? 3, because I got 3 people. What's probably the first one dislikes it? 0.26. What's probably the next one dislikes it? 0.26. What's probably the last one likes it? 0.74. And now you just got to throw that in your calculator and multiply it out. So when we have a large population like America, 340 million people, I forget, then you don't have to worry about, I wouldn't figure out what 26% of that is and then put it over 340 million and then make it 339,999,000. No, that's crazy. It basically doesn't change from 0.26. So if I said I want 8 people and I want all of them to like it, it would be 0.74 times 0.74 times 0.74, 8 times, right? 0.74 to the 8th power. Just like this is 0.26 squared times 0.74. Why does it make physical sense? Because I got 2 freaking people that don't like it. You don't have to write it like that, but still, it's kind of nice. And it relates to something we're going to do relatively soon. So what do you get when you do that? Somebody help me out?
0.05. 0.05.
Dissension in the ranks.
0.05%.
0.26 squared times 0.74. I like 0.05. 0500. Good. 4 places is still 0500. How are we doing there? Is that cool? Not too bad. So that kind of problem is exactly the same as this kind of problem, except this kind of problem has a very small population. There's a very small group of candy bars. The first one has a lot of people. So I just have to multiply their percentages together. Here I got to set the fractions up and change them as I go, because they will change quite a bit. What about part B? All 3 dislike the plan. What's that look like? Yeah, D. Oh, D. 0.26 cubed. Is that cool? What do you get there? 76, right? You good? Okay.
How do you want that rounded as a percentage? Or do you want to?
Oh, then you can just make that straight into 1.76%. Leave it the same as that. Yeah. So round the decimal, and then if you want to, you can make it a percentage. Here I said round decimal answers to 4 places, right? I'll probably say the exact same thing on the actual quiz. Once you do that, you can make them a percentage if you want to. Just see the 1.76%. Just be sure you know how to change from decimal to percent twice. Hey, when people make a mistake there, I'm like, oh shit. Oh man, what do we remember about at least 1? Yes. What's the opposite of at least 1 likes it? None of them like it. Opposite of they all like it is that none of them like it. If I said, oh man, at least 1 person likes this plan, how would you show me I'm wrong? Nobody likes the plan, man, you're crazy, right? So the opposite of at least 1 is none like it, which means they all, well, maybe not hate it, dislike it. Yeah, some of them probably hate it, but we'll just say dislike it. So isn't that going to be this? Did we just calculate this thing? Yeah. Well, I have my 5th puberty. So it'll be 1 minus 0.0176. Do you guys see that? Do you guys understand? I'm going to do the exact same thing. I'm telling you. You just have to either remember I just said that or know how to do it. It'll be sitting right there for you. So, several things. The opposite of at least 1 likes it is no one likes it, or all of them dislike it, right? How do opposite probabilities relate? 1 is 1 minus the other one. So how do I calculate the probability of at least 1? I could do 1 minus the opposite of that, which is all of them didn't like it. So doing this work is answering that question, because they're the same probability. Opposite probabilities are 1 minus each other. And then what do you get there? 9, 8, 2, 4. Cool. Let me just show you this. I know you got your calculator. I don't care. A quick way to subtract from 1 Make everything 9, except the last one make it 10. What do I mean? What do you add to 0 to make it 9? 9. What do you add to 1 to make it 9? 8. What do you add to 7 to make it 9? What do you add to 6 to make it 10? Hey, there you go. So that works with everything, every decimal less than 1.
It has a name.
Hey, what is it?
All from 9, 1 from less 1 from 10. It's in Vedic math.
Invading maths?
Vedic math, yeah, from ancient
Oh.
age. All from 9, less from 10.
All right. I like it. I don't know. It's something that I've just done forever. All right.
All that is
How are we doing so far?
like,
Anytime you see... Guys. Why do I want a different way to do that? What would it mean to have at least one like it? Maybe the first one likes it and the other two don't. Maybe the middle one likes it and the other two. Maybe the last one likes it and the other two. Maybe the first two like it. Maybe the last one, maybe they all like it. Oh my God, it's just too many. I could do all those and add them all up and I would get the answer. I'd much rather just do 1 minus the only one I left out. Maybe. If you add all the probabilities together, it makes 1. So if I do 1 minus the only one that leaves out, the answer that's left is that probability, because that's everything else. That's what's left over is that. Okay. Now, number 2. Number 1, on part I on number 2, I was a little bit evil. I don't know if anybody tried it. But I like this question because it leads us back into the idea of trees. Let's see what I have. There we go. So tell me this. I'm going to pick how many candy bars?
13.
3 of them.
3.
What could the first one be? Hold on a second. Guys. I'll tell you that if you're not paying attention, do not complain to me if you do poorly. You understand? That will piss me off so much. But if you are paying attention, do poorly, we got to do something about that. But pay attention. That's the first thing. The first candy bar I picked, what could I pick? Twix? Snickers? Or Butterfinger. Okay, that's the first pick. It could be any of those 3. If I pick a Twix first, what could I then pick next? Another Twix? Or? Snickers?
Another Twix.
Well, all right, I want to make this really clear. If I said to you, all right, what could happen if I have this situation? And you said, well, you can get a Twix, Twix, and Twix. Or a Twix, Twix, and a Twix. Or a Twix. I'm like, you already said that, man. So the number of candy bars goes into the probabilities, right? If there's a lot of Twix bars, then the probability of Twix, Twix, Twix will be really high, right? But the actual what could happen, it would just be TTT. And then stop with that. And then go to TTS, maybe, the next thing. I don't have to say it over and over. You already said it once. You're gone. Go to the next thing. I like it. I don't know if you guys realize what we're doing here, but if I go one more, this is the second one. Now, I do that same thing off of each of these, wouldn't I? Because if I pick a Snickers, what can I pick next? Twix, Snickers, Butterfinger. If I pick a Butterfinger first, I can pick a Twix, Snickers, Butterfinger. And then over here, I can pick a... I guess... You guys get that? So then, this is a little bit bigger of a tree than I meant to make you make, but oh well. TTT is one outcome. TTS. TTB. Then you go to the next. You guys see where I got those? T, 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 S. T, T, B. So it's just like driving a car and how you can go left or right. All right, I'm going to go left. Okay, now that you've turned left, now you can do these things. And you just collect all the choices you can make. So then it would be TS, T, TS, S, T, S, B. And you just keep going. Yes, sir?
So if we get that problem on the quiz, like it says that we have to fill that out.
Yeah, and I'll give you a smaller one. I think I changed the numbers and then forgot to change the question. So, you know what I mean?
Yeah.
I didn't mean to make it... How many outcomes will there be? How many choices do you have for the first one? 3. For each of those, how many choices do you then have? 3. For each of those, how many choices? 3. 3 times 3 times 3 is 27. The list would be 27 long. Oh, right? It's not that bad. Okay, but this is the basic idea of a tree. The branches are all the next choice you can make. Just like driving down the street, you can turn this way or that way. So if I'm driving down the street, I can go that way or that way, and then I can go this way straight or that way. It's exactly the same idea. Every time I have a choice, it's another branching, right? You guys didn't watch any parallel universe stuff, then I think it's really neat. But oh, we won't go there. Let's just stick with the one universe. Are the outcomes equally likely? Let me ask you this way instead. What's the most likely thing to happen? I've got it written down already. What's the most likely thing to happen here? Why Twix, Twix, Twix? So then let me ask this question again. Are these all equally likely? Based on what you just said, you just gave it away to yourself. If TTT is the most likely thing, they can't all be equally likely. That is based on how many of the candy bars are. If I had 30 Snickers bars up there instead of 5, then SSS would be the most likely thing, of course. So many freaking Snickers bars. And I don't like Snickers, man. Damn it. Dump it out. You guys understand what I'm saying?
Yes.
So they're not equally likely. Why were girl and boy and all that equally likely? Because we assumed they were both 50-50, so they came out to be equally likely. Here they're not 50-50 because there's more Twix. So then how do I find these individual probabilities then? The probability of TT. What's the probability of T by itself? 7 out of 13. What's the probability of S? 5 out of 13. What's the probability of Butterfinger? 1 out of 13. All right. So what's probably TTS if I do this with replacement? Yeah, what's probably the first one's a Twix? 7 out of 13. You put that one back in because it's with replacement. What's probably the next one's a Twix? 7 out of 13. You put that one back in. What's probably the next one's a Snickers bar? And then you just plug that in the calculator. If you ever write the probability down and it's bigger than 1, don't just leave it. You know that's impossible. Right? Don't tell me your coach makes you give 110%. That's all mental. This is hard numbers, right? There can't be a 120% chance of rain tomorrow. What does that mean? So much rain. The land will go like super mega rain. What the hell does that mean? You guys understand? No? Yes? Okay. Did anybody do that for me? I can do that.
0.1115.
1115, I like it. Now, real quick, let me just do this one right down below. It's the same exact question, but can somebody tell me what's the only difference going to be? The first one's a Twix. I haven't done anything yet, so what's that probability? 7 out of 13. Not what I wanted, but I eat it anyway, and then I go back in.
6 out of 4.
Good, there's one less Twickers. I keep on saying Twickers. One less Twix, and one less candy bar.
5 out of 11.
Now let's probably get a Snickers bar at the end. Or Snips.
5 out of 11.
Yeah, there's 5 Snickers bars still, but there's one less candy bar. You guys see the difference between those? With replacements, things don't change. I'm glad you get so much amusement out of it. Inability to speak. And then the numbers will change as you go through if it's without replacement. What do you guys get for this, anybody?
1, 2, 2, 4. 1, 2, 2, 4.
1, 2, 2, 4? So what do you guys got? Validation? Yep. You. Too old? No? You guys get that? Okay. Alright, so then the rest of these should be really straightforward then. Hopefully, right? What's probably BBT? 1 out of 13 times 1 out of 13 times 7 out of 13.
Wait, the second one should be 0 out of 12.
No,
That's replacement.
we're doing it with replacement. We'll do without replacement in a second. Thank you, though. Keep me honest. I like that. Wait a minute, Mr. Wallace.
Okay. 0, 0.
I like it. 0032, kick ass. Now, since you guys are there, the first one's a Butterfinger would be 1 out of 13, but now I ate that because I'm doing this without replacement, so the probably next one's a Butterfinger 0, so that probably comes out to be,
0.
that's impossible. I have 1 Butterfinger, so I can't pick 2 if I'm not putting them back in. The first one is okay because I'm putting them back in. I could get another one out, but what's the probability it's going to happen? Really low. There's only 1 Butterfinger in there. Alright. Yeah, I'm going to have to get some candy bars on the way home now. What's probably
5 out of 13.
5 out of 13 to the
5 out of
3rd power. You can do that quickly. If it's a with replacement, they won't change. 5 out of 13 times 5 out of 13 times 5 out of 13. Just do it to the 3rd power, and what do you get?
0, 5, 6, 9.
Oops. 069?
5, 6, 9.
0569. 0569. Let me stop there for a second. Yeah, once you see one of these problems, you get the idea. But you know I'm going to give you several, so you got to watch out for the ones that there aren't enough of, that there'll be 0 probability. What happens down here now would be 5 out of 13 for the first Snickers bar.
4 out of 12.
1 less Snickers, 1 less bar.
3 out of
1 less
12.
Snickers, 1 less bar. What do you guys get for that?
5, 0.
I like it. If you forgot how to round correctly, if you don't, just go a few more places out. I won't kill you on that. But, you know, it's 496 or whatever, so you got like 5 up. What's up? You alright? What's happening?
There's a laser pointer
Where is it? There's a laser?
Yeah, okay, there you go.
Oh, that's neat.
Is it power? Do I have what bit me? Okay.
Where's it?
I don't know.
Oh, it's on you. It's on you.
Oh, you're pressing the remote from the...
Oh, neato. That's so freaky. Part of my brain was like, oh shit. Is it coming from out there? Oh boy. Alright. Sorry about that. Too much drama. Where's Jack Bauer? Tell me where it is. Alright. That was exciting. Now this problem, we've done this problem a few times already. So you know the routine. But it's the idea of getting all the totals so I can make all the individual probabilities up. So here, if I add all these up, 191, 269, 90. What's this here? 275, I think this is the same, right? So then you end up with 550. Oh, done it all next motion. No, that's not part.
Well, that's tricky.
I know, but still, it's close enough for me. It was a greedy luck this game. Alright. So what's the probability that... Now, real quick, what's the only problem in here that won't start with a 550 on the bottom, or is there more than one? Which problem or problems will not have a 550? D. Because D is the only one where I give you information. Everything else you have a 550 on the bottom, at least to start with, before you reduce or whatever you want to do. So that person is male is how many out of 550? 275. I like it. And that, of course, is 50%. You should know that the vote is 50-50. Too easy. Okay, I got you. I'll keep note of that. I like that. owns a Ford or is female. So how many are female? 275. How many Ford owners have we not counted yet? 124. So if I count all the women, I've counted all these people, I've counted these people, right? How many Ford owners have I not counted yet? Those. That's the direct way to do it. Now, if you want to do it more like the formula, you can say, let me add up all the women, let me add up all the Ford owners, and then I'll subtract the ones I counted twice. But what is 191 minus 67? 124 is where it came from, right? So there's a shortcut to doing it because I can just count this stuff. But if you want to do more like the formula, it'll come out the same. Just got a little more work to do. All over what? 550. What do you guys get?
0.7255.
0.7255?
55.
How's that? Now this is the one that confuses the hell out of you. This is especially the one that if you try to use a formula, you will get it wrong. Because I don't know if they're independent or not. I have to know that. But I can just count how many match what I'm looking for. They have to be a female